Hello and welcome to the Data and AI Summit 2022. My name's Terry McCann. I'm the Director of Artificial Intelligence at a company called Advancing Analytics in the UK. Today, what we're going to be talking about is how you go about building a data science as a service platform in Azure using Azure Databricks. So what we're going to look to cover today is a number of different things. We're going to look at the different data science personas that will be in your business. We'll talk about the challenge that it is to actually support all of these different personas. We'll talk a little bit about how you go about enabling all of these users to achieve more with AI. And then we'll look at Azure Machine Learning, MLflow, and Azure Databricks, and how you can go about combining these tools together to build a platform that really enables every member of your organization to achieve more with AI and machine learning. Now, in your organization, you might have a core team of data scientists, and they may form your primary persona for a lot of machine learning and AI. But when you start to look wider across the business, you start to find other areas of the business that really are trying to engage in machine learning, but they might not have the same level of skills as you would want from your core data science team. And as a result, we want to make sure that we are building platforms that really enable everybody in the organization to take advantage of machine learning. Because if we're not, we're limiting the amount of flexibility and we're limiting the amount of power that we have of machine learning by reducing the scope of who can play in machine learning just to that single team. So looking at the different personas across the business, we can start at the kind of bottom, or rather at the top really here, which is the core of who our audience are, who are our data science and our machine learning engineers. This is the audience who are best placed to take advantage of machine learning and are the ones who typically have the most skills, right? So they're typically experienced machine learning developers. They're experienced in both deep and shallow machine learning. They typically come from a kind of deep Python-based background, and they're very comfortable in building out notebooks and working in that particular way. And they typically know R, Scala, and other machine learning languages, right? This is the core that most platforms are built around. They're the easy target market who we know we can serve with a platform like Databricks. But what about some of the other kind of key individuals you might have across your business? What about somebody like a data analyst? Now, a data analyst typically is very experienced in things like SQL and data, and they might be very good at being able to take some data and tell a really compelling story about what it is trying to show. But the problem is they have a very naive understanding of machine learning, but they might have a deep interest in machine learning, and they probably have a load of great ideas about how it could be applied because they are so close and so deep into the data that surrounds it. But they really don't know enough about Python or R to really get started with machine learning. Then next you might have the more senior analyst, the more experienced team, so a similar set of skills, but they might know more about machine learning. They might know the process that we would typically want to go through. But again, they might not have the pure Python skills to actually spin up a notebook and comfortably write a model which is free of bias and is designed to ultimately generalize to the problem we're trying to solve. But again, they have lots of great ideas. Then the other persona, which is kind of often neglected in a lot of organizations, is this of the kind of advanced business user. And we're not kind of thinking necessarily about an operational business user here. We're more focused around an area of the business that is typically doing very data intensive operations. And that could be somebody in finance who's producing forecasting models. That could be somebody in kind of procurement, and they're looking at how we're optimizing our supply chain. It could be looking at revenue forecasting and trying different models and applying things like Monte Carlo models to ultimately optimize those models. There might be somebody from an actuarial background who's very used at building out large-scale risk models in things like R, and are building out a model that they just need to get live, but they're struggling to get these things live. These are the kind of audience that we also need to think about enabling as we go. So what do we also need to think about with this, right? When you start thinking about each one of these roles, you can begin to kind of plot them on a bit of a maturity curve, right? It is kind of how mature they are with machine learning compared to the kind of complexity of the tasks that they might be involved in solving. And what you typically find is you end up with a curve like this. When you've got a very shallow, naive understanding of machine learning, the type of complex problems that you're trying to solve are also quite shallow. And as that machine learning maturity increases, as does the ability for you to be able to solve more complex problems. And if we start to plot out our different personas, what we can see is that our data analysts are very low in our kind of priority here, but we want to make sure that they are able to achieve as much as they possibly can. Our senior analysts, slightly more mature, slightly looking to take on slightly more complex problems. Our advanced business users are potentially looking to try some even more advanced techniques. And then ultimately our data scientists and our machine learning engineers, who are very comfortable with working in notebooks and that kind of whole environment, will be looking to take on much higher complexity problems. And this kind of leads into the challenge, right? And the challenge is that really trying to achieve a kind of balance with all of these different roles is almost impossible, right? How do you provide a platform that on one hand enables somebody to just run any model they want, enables another user to be able to just write notebooks, and another user who doesn't necessarily know about machine learning to achieve as much as they possibly can? It's very difficult. And that's part of the challenge that we're trying to solve in this talk today, right? It's because this challenge here, it is really hard to achieve. But we've got a number of different ways in which we can try and do this. So if we think a little bit about what might enable each one of these kind of personas to achieve the most, we can start looking at them in this terms, right? A data analyst, they're low in terms of complexity and they're low in terms of machine learning maturity, but they've got a great idea and they want to get started. How could we enable that user? Well, Automl, right, would be a great option here. Automl being automated machine learning. Rather than having that user actually go in and try to build out this model in a notebook, what we're actually going to say is, I've provisioned some data for you. You know roughly what you're trying to achieve. So rather than you doing it, why don't you try 100 different models and try to find one which roughly solves the problem that you're looking for, and test it out. Now, it might not be a perfect model. It might be a great opportunity for that person to learn from what's happening, or it might be a great kind of exercise that is then taken forward by the experienced machine learning developers and taken forward into an actual production scale system. Now, what about our senior analysts? Well, now they might be more experienced in what they're doing, and they generally understand the kind of 7 steps of machine learning, from going to get some data, to cleaning it up, to choosing an algorithm, to actually training a model, to doing hyperparameter tuning, to then actually trying to squeeze this out and productionize that model, right? They might understand those steps and what they need to do, but again, they might not be comfortable with actually doing that in Python. They want to do it in a kind of GUI-based way, in a user environment, right? Then what about our advanced business users? They're realistically not going to be building things out in the tool set that we are using. They might be doing stuff locally. They might be using an industry standard tool that generates a model in a particular format, like PMML or an Onyx model or something like this, that we can integrate back in with. And then that small experienced user who we know the platform works for, they want to do real-time development, they want to do notebook development, they want to get an environment that really enables them to achieve more and hopefully gets them off working on their local machine and in an environment that works in a very consistent way and overcomes some of the challenges that you typically find in very desktop-heavy machine learning environments. So how do we enable all users, right, to achieve as much as possible? When we start looking at this picture, we need to start thinking about, well, what is the best tool to enable each one of these users? And that could be Databricks, right? That could be something like MLflow, or that could be an alternative tool such as something like Azure Machine Learning. And for each one of these different types of ways of working, there are a number of different components that we could try to use. Now, ideally, we want to try and reduce the scope as much as possible, but there are some parts that are available in Databricks and there are some parts that aren't. So looking at applying each one of these to each one of our kind of environments, we end up with something that looks like this. Now, if we're looking at AutoML, we've got two different options. We actually have a load of different options, but primarily we're looking at this core list, and that's two. And that is, you could either do your AutoML inside Databricks or you could do it inside Azure Machine Learning. And there are pros and cons to both, and they're quite similar in their approach. But what Databricks gives you and has kind of given you from the start is it will give you the notebook and all of the code used to actually generate that model. And not only is that good for how you go about retraining a model further down the line, but it's also great as a learning experience to show somebody how you go from taking a model and doing AutoML to it generating the steps that you need to go through to actually build that out. And that can be a really powerful tool to enable those users to learn more and to start taking on more complex scenarios. Our senior analyst who might want to look at a kind of GUI-based approach, we don't have that in Databricks, right? So there we need to look at an alternative tool such as something like Azure Machine Learning, where we do have that very GUI-based focus, and we can drag and drop and clicky click, and we can build out a model that is so-so. It might not be as good as something we can build by hand, but it does enable you to do rapid prototyping and enable that kind of user to achieve more. Now, when it comes to serving any model, we have to think about how we're serving the model. Is it real time? Is it batch? And we need an environment that's capable for doing both. And that's where Databricks with MLflow comes in, and with Databricks serving up a managed MLflow instance that we can use. So we're able to take a model, register it in our model registry, and then choose how we consume that. Do we consume that in a real-time process, or do we consume that in batch, and what does that look like? Then to enable our normal users, we want to be looking at their notebooks and kind of just sprinkling a little bit of MLflow over the top, right? It's the icing on top of the cake. It's the stuff that really helps them achieve more, and it helps them do things like model management. It helps them understand experimentation tracking and all of these pieces, and it really just kind of sets the scene, right? And that's what we want to be looking at throughout this process. So building the right platform, what are we going to look at? Right now, it is best for us to go and have a little look at a demo and step through and walk through some of these different scenarios. So we'll take a look at how Databricks implements AutoML. We'll look a little bit at managed MLflow and how you can use MLflow inside Databricks. And then we'll look at MLflow model serving for real-time serving and how that can enable us to just kind of fire multiple different requests off to an API and get a sense for a real-time model served in real time. So let's have a little look at this. Let's switch over to Databricks. And here I am in my Databricks workspace. Zoom in a teeny bit so you can see a little bit better. And first of all, what we're going to look to do is we're going to look to train a model using AutoML, okay? So the first thing that you need to do with AutoML is you need to have some data registered into Hive. So here I've got a database called AutoML, and I've got a table in here called Bike Rentals Terry. And this is the normal bike rental data that you may be very familiar with, which is great for doing demos such as this. And what you can see in this data is you've got a number of different features which have all already been encoded for us. And then you've got this column at the end here, which is our label, which is count. And it's this that we're going to look to try to predict. So if we hop back to our home page, up the top here, what you'll see is this option for AutoML. And you've got this first button here, Start AutoML. So if we click into that, you're given this kind of configuration option here. And if we have a look here, you've got this AutoML experiment configuration. It says it needs to be running on ML runtime 3.8 or above. And so what we're going to do is we're going to select our cluster. And it says, what problem are you trying to solve? Well, for us, that's a regression problem. Or you could also argue it's a forecasting problem because it does have a time series. But for now, we're just going to say it's a regression problem, okay? And it says I'm going to want you to browse to that data set. So I go to Automl and I choose my bike rental. And I say I'd like to select that. And if we zoom back out, what you can see here is all of the columns that have been already kind of provided for us. And we can say the prediction column that we're interested in is count. And we'll give it this just generic experimentation name. But there's a couple of things in here that I need to clear up. I don't want to use these two columns, casual and registered. And so what I want to do then is just remove those. If I wanted to do something here and I wanted to impute missing values, I could do that. This data set is incredibly clean and has very few missing values, so I don't really need to do a great deal of this. When I'm happy with all of these configuration options, all I do is hit Start Automl. And then once that has started, what you'll start seeing is, it says up here, right, what it's going to do, it's going to start running these Automl experiments. So you can see here it's just getting things ready. And then slowly what we'll see is models will start appearing here as they are going through this Automl process. And so to just remind you, right, this is going through and it's taking our model and it's trying a number of different approaches to really achieve the best outcome that we could possibly expect. And if we hit refresh, we will slowly start seeing models appearing in here. So here we can see our first one is beginning to appear. And slowly what we'll see is more and more models will appear. Now, here's one I made earlier, and this one is still currently running, but what you can see is that a number of different models have been tried. And you can see at the moment, the best model that we have is an XGBoost model, which apparently is also using a scikit-learn model, and it is producing the following outputs. So we can see that there's an R-squared value of 93, which is very high, very well correlated this data is. And what we can do is we can actually say, well, I'd like to click into this, and I'd like to understand about how it's actually working. And I could start following this through. So I can see how the data is being loaded, and I can see the data here. I can see the columns that it's using, any pre-processing that's being applied to it, any categorical encoding, all these kind of things, standardization with features. Now, a lot of this has already been provided to this data, so it's a little bit overkill, and probably some of this could be removed. But then what we end up with is our XGBoost regressor, and we can see a bit of help about here. And then we can see the configuration that it has chosen for this particular model. And we can see a kind of view of the pipeline that it's going to go through and the approaches that are going to be taken. So we get a really useful kind of graphical representation here. And then what we get is a little bit of ML flow to really show what is happening. And we can see the comparison between our validation and our test sets. And we can see that we're generally getting a model that tracks incredibly well for what we're trying to produce. So with all of this, what we're able to do then is start thinking about, well, I could take this and put it in production. And that would be a great approach if we wanted just to try something out. So what AutoML can do is really enable those users to start building things out and start taking a model from nothing almost to a production grade model very quickly. And then when somebody wants to come in and really learn and understand, they've got a great deal of information, they've got a great deal of documentation that they can follow through to really understand how that model was built. But what if you're familiar with this, right? You're already building out notebooks. You're that more kind of advanced user, maybe a business user or maybe a data scientist. And what you want to do is you just want to take a model that you've already potentially built and you want to be able to do some more with it. So if we go back into our workspace and I come back down to our Data and AI Summit, I've got a notebook here, which is how we can do a very similar thing. However, rather than looking at how we do this with like AutoML, we want to do this ourselves. So what we can do is we can import a couple of different packages here and we can load our data in. And then we can start using MLflow. So you'll see here with MLflow, I've started an initial run and I've started to bring in a few different things here. So I've brought in a random forest regressor. I'm going to change that one out to a GBT regressor. I'm just going to hit run all on this. And what we started to do is we started to bring our data in and train our model. And you can see here we're setting a couple of parameters. And then we're going to train our actual model just using a standard kind of SparkML approach. And we're going to look at a couple of predictions. We've got a slightly faulty run, so we're just going to correct this one here with an MLflow end run just to cancel that previous running instance. And just close that one and run that one all again. And so what you'll start seeing is as this model begins to train, we will start being able to start tracking what we're seeing here. So we'll be able to start understanding what is going on with this model and how is it performing. So we'll start being able to see things like, well, what is the root mean squared error and what is this doing? And anyone who's kind of eagle-eyed will notice that there's a new little one that has popped up here. And that's showing us that there's an experiment taking place currently. And if I click into that, what it's done is it's produced this little snippet of what's kind of happening currently. And what I can see here is if I refresh, I've got maybe this particular one here where I'm starting to log out some values. So I'm starting to log out what's kind of happening with my model. If we use this as an example, right? I've started logging out a number of different things. I wanted to know how many iterators I've had, how many numbers of trees, and how was the tree depth. And when I used this particular configuration, what were the hyperparameters? So the R squared was of a 92.9, very similar to what we were seeing with the Automl approach, with a root mean squared error of 48.55. So an okay model, but something that certainly could be improved. Now that's certainly one approach to this process, but that's quite a lot, right? There's quite a lot going into there. To log those metrics out, we need to repeatedly write things like mlflow.logmetric and really try to get this stuff working as much as possible. There's quite a lot of manual steps and stages involved. Now, because we're looking at newer versions of MLflow, and MLflow is constantly kind of improving, we have new things available to us. And one of them is this thing here, auto-logging. Now, what auto-logging will do is it gives you the ability to say, well, there are some things that I definitely want to log, but generally I don't want to be like explicitly saying capture every type of parameter and every kind of loss metric. What I want you to capture is just the important things. And you can enable that here by saying, I'd like to import mlflow.spark, and I would like to turn on auto logging. And you need to use this particular version when you're working with Databricks. And when that is turned on, what that will do is that will say any parameters and any kind of inputs that we have here, I want this just to be captured. So what I can do is I can take a very similar query and a very similar process. Say I'd like to start my run. And now this time, rather than logging everything, I'm just logging a couple of different things here. I'm logging the artifact and then I'm ending the run. And so what I'm able to achieve here now is if we go and look at our experiment, rather than, if we go over here, rather than just these couple of additional parameters here, what we're able to see is a huge list of everything that's gone into that model. Now, rather than I would have to go through and add these all in manually, what I've done is just done that in an automated way. And we can see the same thing for that R squared and that root mean squared error, albeit this model has decreased in its kind of in its success. But we can see a lot of that happening, and that's all happening via that auto logging. And most importantly now, what we also have is this model's Spark here. And so it's here that we can start thinking about how we go about enabling all those different users, and where I can begin registering my model. And so now I've got a trained model that I might want to put live in some way. So I could choose in here to say, I would actually like to register this model, and I'd like to create a new model. I'd like to call it Data and AI Summit. and I'll register that model. And you can see that registration is pending. And if I click into that model there, as that's being registered, I can start looking at this and start understanding the different processes that it's been through. And up here in the top, we've got this button here, use this model for inference. And it's here where we can start thinking about, well, what do I want to do with this? Do I want to build out a batch model or a real-time model? And this real-time model here is super interesting. That gives us the ability to spin up a REST API incredibly quickly and enable us to start looking at how we can start firing requests at that. Now, it takes a little bit of time to spin up. So what I'm going to do is I'm going to go and have a look at one that I've built out already, which is this model down here. And up here, you've got this option here for serving. And now with this serving here, what you get is a kind of Swagger-like API where you can say, well, I would like to start sending some requests to this model in order to see what kind of responses I'm getting back. And it's expecting some JSON. So what we'll do is we'll go and get some JSON to populate this. I'm just going to get back to my workspace. I'm going to come down to my API call here. And I'm just going to take a packet that it's expecting to see. And so what I can do is if I paste this in, let's copy that again. And paste that one in and send that request. What you'll see is I'm getting a response back almost immediately. And what I can do here is I can actually just copy this. And I could say, well, what I'd quite like to do is actually just try this with a couple of different parameters with the working day actually set to 5 and see the difference in the responses that I would get back. Working day isn't available there. Let's have a look at actually changing the hour to 12 and send that request. And we can see here slightly different. Let's change that one around to 22 and see if we can find something a bit different. And here you can see we've got two very different responses coming back. 191 and 157. And now what you can do is you can really start thinking about taking this one step further by building this around and putting a kind of API process in here. So what you would be looking to do with a kind of notebook like this is just simulate how your process might be working from a live system. And so what I'm able to do is to take a little bit of data and able to start getting some scores back in real time by just sending a JSON packet to that API. And what you'll be able to see here is if I change some of these values around a little bit, we'll start seeing these numbers changing here. So from 102 down here, that one didn't change it enough. Let's change something like the hour back down to 1 and run that one again. What we're able to see is those numbers are changing. And we're able to build this out. Now, this might look like an awful lot of code that you need to write that you might not be very familiar with. But don't worry, because you've actually got that all available here, and you pretty much all you need to do is copy and paste, and you're up and running with this. So when it comes to thinking about how we build out an environment that really enables all of these users, through a combination of Databricks, MLflow, and Azure Machine Learning, we're able to begin to enable all of these users to really begin to achieve more with a platform such as Azure Databricks. So in closing, what I kind of want to leave you with the message, the overarching message that when we're building out machine learning platforms, we want to meet everyone where they are with an architecture that supports multiple data science personas. Because you might just have one core group, but there are many more that you might want to work with. We want to enable everyone to achieve more with advanced analytics and artificial intelligence. And so if you want to get in contact with me, please do. You'll find all my details here. If you're at the event, I will be at the event as well, walking around. So do please come and grab me. We love talking about all of this stuff. Thank you very much for your attendance and for your viewing. I hope you have a phenomenal Data and AI Summit, and I will see you at the next one.